I wanted to produce a short little Google Earth video here that takes some of the climate classification information that you've been learning about in the book and in the lecture and put it in the context of Alaska. And I'm going to do this using a set of Google Earth data that's been produced by an Alaska climatologist, Brian Bretschneider, and you're actually going to be using these same data but for the lower 48. But you'll see that the data set that you'll have will include the Alaska information. So here's Alaska, and you can see a whole bunch of little purple symbols all over. These are all different symbols that represent different climate classifications. So let's go and take a look at them, and we'll actually start up on the North Slope, where we've got some of Alaska's most interesting climate classifications, I think. Any place along the North Slope here, we can click on one of these and we can say that this is a Köppen tundra climate, or ET classification, which is what we would expect for the North Slope. It has very cold temperatures. You can see that in July, the high temperature of the year gets up to, on average, 44 degrees. Well, that's the average for the month. And you can see it's significantly colder than that during the winter. February is minus 17. Very little precipitation as well. The wettest month is July, also the warmest, not surprising, where they get only a little over 1 inch of precipitation in that one particular month. So let's go back and now take a look at some of the other climate types. Let's first go to the interior of Alaska, and we'll go down into sort of the broader Fairbanks region. And you'll see that there are a lot of purple squares here. And these are all going to be microthermal climates. And if we click on any one of them, we'll see that they are continental subarctic climates. These are ones with year-round precipitation, but you'll see that there's a C at the end, and that is a designation that we have relatively cool temperatures throughout the course of key months. Precipitation, again, is greatest in the summer when the temperature is the warmest, but here we don't have quite as much of a cold temperature as we did up in the North Slope. The average January temperature is -3. That's the coldest. It gets up to a balmy 58 degrees in July. We can take a look at some of these other ones here. This is a DWC, which is a continental subarctic with a dry winter. And so this is a particular climate station that, as a result of microclimates, gets just a little bit less precipitation during the winter, probably because it's a little bit colder. It's Nenana, by the way. And as a result of that, it ends up with a slightly different climate classification. If we slide down to South Central Alaska, we'll see that we have many of these same climates and climate types. Now, we all know that the weather in Anchorage and the climate in Anchorage is not quite as brutal as it is in the interior, but that's one of the problems with climate classification. This whole issue of homogeneity means that we tend to group areas together that actually do have a lot of differences between them. But if we take a look at some of these individual ones, we'll click on this one right here. This is Fort Rich. You'll see that this is a continental subarctic climate as well, but this one has a dry summer to it. So it's just a little bit different. It's a DSC climate. Go back to the main South Central look right here, and let's click actually on Girdwood and fly into there. And when we take a look at this particular climate station, we'll see that it is a DFC, just like those ones we saw in the interior, continental subarctic, with year-round precipitation. So again, some of the problems with homogeneity sort of show up here. Let's go back out to Alaska as a whole now. Let's go someplace where things really are quite different, and we'll fly down to Southeast Alaska. And you'll see that a lot of these microthermal climates are up in the northern part. Some of them look a little bit different, like this one right here, which is Hoonah, that has a DFB climate. This is a continental warm summer, so things are changing a little bit. But as we get down, in and around Kodiak and Ketchikan and the southern portions of this climate, here's Sitka, you'll see that we get into a mesothermal climate, CFB, and that is a climate that is one of these marine west coast climates. And you can see a lot more precipitation down here because we have warmer temperatures all year round. Although the total fluctuation is relatively small. The January temperature is actually on average 36 degrees, and the warmest month is August at 57 degrees. But here we're starting to see a real variation. Note though that as soon as you go inland just a little bit, you start to get into that microthermal climate again, because you lose some of the very strong maritime effects that these areas get out on the west coast. And then the last place that we're going to go after we look at Alaska again is out in the Aleutians, where we really have a number of different things happening. Of course, Adak is the farthest southern part of Alaska. We might not think of it that way, but if we click on that, you'll see that it is one of these mesothermal marine west coast climates. It's subarctic though, CFC, a marine subarctic climate. Those are actually fairly rare. If we take a look up here at St. Paul Island, you'll see it's a tundra climate. But then once we start to get to the Alaska Peninsula or out into the really far Aleutians where we start to get some Siberian effect out there, or here we just get a little bit more continental effect in Cold Bay as a result of being on a landmass, we start to get into those mesothermal or those microthermal climates again. So a lot of variation in climate around Alaska, maybe not as much variation as we'd see in the lower 48, of course. Got a lot of subarctic sorts of climates in the state, but you'll see that there is some differentiation among all of this homogeneity.